For more than 60 years, humanity has been looking back at itself. We have built machines of exploration, metal glass silicon, and sent them on journeys into the great cosmic ocean. These voyages have taken us to other worlds, distant stars, and the very edge of understanding. Yet some of the most profound discoveries, the most humbling moments, have come not from looking out, but from turning our cameras around. NASA, our collective eyes in the sky, has given us a perspective of our home planet that no generation before us could have imagined. This is a story about that view. It is a journey of perspective, from just above the air we breathe to the cold, silent depths of interstellar space. This unique vantage point is not just about pretty pictures, it is about understanding. It is about science. From these orbital perches and deep space probes, we see our world as a single, interconnected system. We see the swirling patterns of our weather, the slow, powerful dance of continents, the delicate film of our atmosphere. We see the lights of our cities, a testament to our presence, and the vast, dark oceans that cradle life itself. Our journey begins not in the vacuum of space but in the upper reaches of our own atmosphere. Here, at about 13 miles up, flies the NASA ER-2 aircraft. This is a special plane, a scientific platform that soars above 95% of Earth's air. The sky turns a deep dark blue, the curvature of the Earth becomes visible to the pilot's eye. From this altitude, the world below looks different. It is not quite space, but a perspective far beyond our everyday experience. It is the first step on our ladder to the cosmos, a crucial link between the ground we walk on and the space beyond. The ER-2 is like a satellite that can come home. It carries a suite of advanced instruments looking down with incredible precision. Its mission is to study the Earth system from a unique vantage point. It can fly directly over hurricanes to measure their structure and intensity. It can map the chemistry of the upper atmosphere, helping us understand the ozone layer that protects us from the sun's harmful radiation. It can measure the health of forests. It can measure the thickness of ice sheets. The data it gathers is vital for understanding climate change. Think of the ER-2 as a high-flying detective gathering clues about our planet's health. It gives scientists the flexibility to go where the science is, providing a close-up view from a high-altitude perch, invaluable for Earth science. Now, we climb higher. We leave the atmosphere behind and enter the realm of orbit. Our next stop is the International Space Station, or ISS, a football field-sized laboratory circling the Earth at 250 miles up. This is humanity's home in space, a place where astronauts live and work dedicated to science and discovery. From their windows, they have a view that has captivated the world for decades. They see our planet not as a static map, but as a vibrant, living sphere. Continents glide by, storms gather over oceans, lights of cities sparkle in the darkness. Before the ISS, the Space Shuttle program gave us a similar perspective. For 30 years, these reusable space planes carried astronauts and satellites into orbit, often reaching altitudes of up to 400 miles. The images and stories brought back by shuttle astronauts fundamentally changed our relationship with our planet. They showed us the thin, fragile line of our atmosphere. They shared the experience of seeing 16 sunrises and sunsets every single day. It was a window for all of humanity to look through. Their descriptions of Earth's beauty and fragility have a profound impact, fostering a deeper sense of global unity and shared responsibility for our home. What you see is a single shared planet, a beautiful blue marble set against the blackness of space. Our journey continues upward to a fleet of robotic observers that serve as our planet's tireless guardians. At altitudes around 430 miles, we find satellites like Landsat PACE. These are not temporary visitors. They are permanent sentinels, their unblinking eyes constantly scanning the surface below. For over 50 years, the Landsat program has been creating the longest continuous record of Earth's land surfaces, as seen from space. It is a global archive, a detailed history book written in light showing us how our world has changed over decades. The Landsat satellites see the world in ways our eyes cannot. They capture images in different wavelengths of light, including infrared. They can tell the difference between healthy vegetation, stressed vegetation, helping farmers manage their crops, the retreat of glaciers, loss of forest with stunning accuracy. Joining this orbital watch is a new generation of satellites like PACE, which stands for plankton. Essentially, PACE is taking the pulse of the ocean's health from space. Together, missions like Landsat and PACE provide a comprehensive health check for our planet. We now take a giant leap outward, to an altitude of 22,236 miles. Here, we find the GOES satellites, the geostationary operational environmental satellites. Geostationary is a key word. It means these satellites orbit at the exact same speed that the Earth rotates. From our perspective on the ground, they appear to hover motionless in the sky over a single spot. This unique position allows them to keep a constant watch over an entire hemisphere. Goes east watches over the Americas, the Atlantic Ocean. Goes west keeps an eye on the Pacific, the west coast of North America. From this great distance, the GEOS satellites provide the big picture view of our planet. They are our primary weather watchers. The satellite loops you see on the evening news, showing hurricanes swirling toward the coast. Storm systems sweeping across the country come from GOES. They provide continuous imagery that is essential for weather forecasting. But GOES does more than just watch clouds. These advanced satellites also monitor solar flares from the sun, which can disrupt communications and power grids on Earth. They detect forest fires and measure sea surface temperatures, which helps in hurricane intensity forecasting. As we move even farther away, we see views from missions like Messenger, a spacecraft on its way to Mercury. As it departed, it looked back and captured a series of images of the Earth-Moon system from distances of over 270,000 miles. In 1968, humanity ventured farther than ever before. The crew of Apollo 8 became the first humans to leave Earth's orbit and travel to another celestial body, the Moon. Their mission was to circle the Moon and return, but as they rounded the far side of the Moon, some 240,000 miles from home, they saw something unexpected, something that was not in the flight plan. They saw the Earth, rising above the barren gray lunar horizon. It was a sight that would change the world forever. Astronaut William Anders grabbed a camera and captured the moment in a photograph that would become known as Earthrise. It is, honestly, one of the most famous and influential photographs ever taken. For the first time, humanity saw its home not as a vast, unconquerable world, but as a small, delicate, and beautiful sphere of color floating in the vast, black emptiness of space. The brilliant blue of the oceans, the swirling white of the clouds contrasted with the stark, lifeless surface of the Moon in the foreground. It became an icon for the burgeoning environmental movement of the late 1960s and early 1970s. For many, it was the first time they truly grasped the concept of Earth as a finite and fragile system. There were no borders visible, no signs of division, only a single, unified home for all of humanity. More than half a century after Apollo, humanity is returning to the Moon with the Artemis program. This new era of lunar exploration is not just about repeating the past, it is about building a sustainable presence on the Moon during its uncrewed test flight. The Artemis 1 Orion spacecraft traveled farther than any human-rated spacecraft has ever gone, reaching a distance of over 268,000 miles from Earth. From that incredible distance, Orion's cameras looked back and gave us a new Earthrise for the 21st century. It captured stunning high-definition video of our planet, a tiny, brilliant blue marble, peeking out from behind the Moon. We see our planet not as a static image, but as a dynamic world. This new lunar campaign also includes commercial partners, like the Firefly Blue Ghost lander, designed to deliver science payloads. As these robotic explorers make their way to the Moon, they will see our world as a beacon in the sky, a constant reminder of their origin. The perspective from the Artemis generation is one of both nostalgia and ambition. Seeing our small, distant planet hanging in the blackness of space from the vantage point of the Moon is a powerful motivator. Our journey now takes us millions and then hundreds of millions of miles away from home. We travel to other planets, to worlds that are vastly different from our own. And from the surface of these alien landscapes, NASA's robotic explorers have turned their cameras toward the sky to find a familiar sight: home. From the surface of Mars, about 99 million miles away, NASA's Curiosity rover looked up into the twilight sky and captured an image of Earth. In that image, Earth is not a blue marble. It is a single bright evening star shining in the Martian night. Think about that for a moment. Every star you see in our night sky is a distant sun-like object. But from Mars, one of those points of light is us. Now let's travel even farther, to the majestic ringed planet, Saturn. From a distance of nearly 900 million miles, the Cassini spacecraft performed a special maneuver. It positioned itself in Saturn's shadow, and in that stunning mosaic known as the Day the Earth Smiled, there is a tiny pale blue dot hiding between the rings. That dot is Earth.